Today I will be solving the AMC 8 1986 questions 21 to 25. Oops, that's the wrong question. Suppose one of the 8-letter identical squares is included with the 4 squares in the T-shaped figure outlined. How many of the resulting figures can be folded into a topless cubical box? So what's asking for is that they want one of these 8 squares, or one of these 8-lettered squares, to be folded into the final box, and it's asking for how many of these can be folded into a topless cubical box. So visualizing this, we see that A works, B works, D works, F works, H works, and E works. They can all be folded into a topless cubical box, but then when we look at C and G, then we see a problem. Because when you look at this shape formed by, this is a terrible shape. Wait, give me a second. When you see this shape where C is, you notice that this can't be folded into a topless cubical box because the C can't fold. And then this is the same case with G, where G can't be folded into a topless cubical box either. So that leaves us with 6 of the letters that are able to fold into a box. Alan, Beth, Carlos, and Diana were discussing their possible grades in a mathematics class this grading period. Alan said, if I get an A, then Beth will get an A. Beth said, if I get an A, then Carlos will get an A. Carlos said, if I get an A, then Diana will get an A. All of these statements are true, but only 2 of the students received an A. Which 2 received an A? So we see that there's a chain reaction here. So meaning that if Alan gets an A, that means that the rest of them will also get an A. And if Beth gets an A, everyone else after her will get an A. So we can use this information. We can write out a bunch of statements here. So Alan causes Beth to get an A, and then Beth causes, who's next? Carlos to get an A, and then Carlos causes Diana to get an A. So anyone in front that gets an A will cause everyone else behind them to also get an A. So if only 2 of these students received an A, okay, wait. If all these statements are true, but only 2 of the students received an A, which 2 received an A? So logically, we can see that only Carlos and Diana received an A, because that means that them getting an A won't affect anyone else getting an A. So only these 2 received it. So only Carlos and Diana received an A. This is true because if Alan or Beth received an A, that means that the rest of them, all of them, got an A, which does not comply with the statement given in the question of only 2 getting an A. Because say Alan or Beth got an A, that means that all four of them got an A. But then since it's only Carlos and Diana, that means that only 2 of them got an A. So our answer is Carlos and Diana. The large circle has diameter AC. The 2 small circles have their centers on AC and just touch at O, the center of the large circle. If each small circle has a radius of 1, what is the value of the ratio of the area? So, what is the value of the ratio of the area of the shaded region to the area of one of the small circles? So, let's find the area of the small circle. So the radius of the small circle, the radius of the small circle is equal to 1. So we know that it's pi r squared. So so we see that the area is just pi is just pi units pi units squared, and we have to figure out what is the area of the shaded region. So to do this, we must first find out the area of the larger circle, which is the radius is 2, because the radius is equal to the diameter of the smaller circle, which is 1 plus 1, because the 1 is the radius of the smaller circle, and double that is 2, which happens to be radius of the large circle. So to figure this out, we do pi r squared again. This time is 2 squared times pi, which is equal to 4 pi, and then we have to divide by 2 because we only want we only want half of it. 4 pi divided by 2 is equal to 2 pi. But then we also notice that we have to subtract the area of the circles, the smaller circle, from it. So then this is 2 semicircles, which is equal to 1 circle, and then we know the area of 1 circle, which is pi, because these two small circles are equal. So that means that we can just find we can just add up the 2 semicircles together to get pi. So we have to subtract the area of the largest semicircle by the area of the small circle, which is 2 pi minus pi, which equals to pi. And then we can see that the area of the shaded region is pi, but then the area of the not semicircle, smaller circle is also pi. Pi over pi is just 1. Students at King Middle School are divided into 3 groups of equal size for lunch. Each group has lunch at a different time. A computer randomly assigns each student to one of the 3 lunch groups. The probability that the 3 friends, Al, Bob, and Carol, will be assigned to the same lunch group is approximately... Wait, I have the answers here. It's approximately... Whoops. It's approximately blank. So the 600 here is it's not useful because yeah, we just don't need it. We're interested in the 3 groups. So for Al to get into one of the 3 lunch group is 1 out of 3, because there's 3 groups. There's 3 groups for him to get into. That's the same with Bob, because he has a 1/3 chance of getting into any of the 3 groups, and that's also the same with Carol. So then, if we want them to be in the same group, we have to multiply these probabilities, and we get 1 out of 27. Now, this might seem like the correct answer, but we have to remember that there's 3 total groups. That means that they're 3 times as likely to get into the same group. So we have to multiply this 1 over 27 by 3, which is equal to 1 over 9. So they have a 1/9 chance of getting into... Which of the following sets of whole numbers has the largest average? So we want to figure out which set of multiples has the largest average in the range of 1 to 101. So first to figure out, so we have to do casework for all of these. So let's do A. So we want to figure out we want to figure out the number of multiples of 2, right? So we want to do 101 divided by 2 is equal to 50. So that means that there's 50. It's equal to 50.5, but the 0.5 is not the 0.5 of a number is not a multiple, so we only want the 50. Another way of doing this is taking the floor of 101 divided by 2, which is the smallest integer greater than or equal to the n, which is the number inside. So that will be equal to 50. So that means that there's 50 multiples of 2. So what we can do here is that we can write this out as 2 times 1 plus 2 times 2 plus 2 times 3 dot 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 all the way to 2 times 50. What we notice here is that we can oh wait, this is all over 50 because there's 50 terms. What we notice here is that we can factor out the 2 from this. So it will be 2, 1 plus 2 plus 3 all the way to plus 50 all over 50. So what you get left over here is a very nice arithmetic sequence. So we can use the formula n over 2 a1 plus an to figure out the sum of the arithmetic sequence. So then there is 2, so this will be 2 times n. N is the number of terms in this series. So there's 50, so 50 divided by 2. A1 is the first term, 1 plus 50, an is the final term, 50, all over 50. So then solving this will give us the average. So 2 cancels out, the 50 and 50 cancels out, so what we get left over is 51. So the average for set A is 51. Let me write that over here. So now we can do B. So it's the same process here. So it's number of multiples of 3. So it will be 101 divided by 3. We take the floor of that. This will be equal to 33. So in this time, I'm going to skip step 1 here because we can factor out the 3. But then instead of having 50 terms this time, we have 33 terms. So it will be 1 plus 2 plus 3 all the way to 33. And then divide it by the number of terms, which is 33. So we do the same process here, and then this will be equal to n over 2. There's 30. N is equal to 33 over 2. A1 plus an, 1 plus 33 is equal to 34. All over 33. The 3 and the 3, this gives us 11. The 2 and the 34 cancels out, gives us 17. Yeah, 17, and then the 11 and the 33 cancels out, gives us 3. So then 3 times 17 is equal to 51 again. So it means that these two averages are the same. And since these two averages are the same, we know that A and B cannot be right because we can't pick two answers. For the next one, we have multiples of 4. So C, multiples of 4, so it will be 101 by 4. Take the floor of that. No pun intended. Take the floor of that, and we get 25. So then the same process here. 4, there's 25 terms. 4 times 1 plus 2 plus 3, all the way up to 25. All over 25. Then this will be equal to 4 times n, which is 25, because it's 25 terms. If we were to count it all, divided by 2, times a of n, just 1. A of 1, which is 1, plus a of n, which is 25. So this is 26. Remember, we're still using this formula. We're still using this formula over here. All over 25. So we can see that 4 cancels out, so this is just 2. 25 and 25 cancels out. So this entire thing is equal to 52. So C is equal to 52. The average of C is 52. And then now we can do D. So in D, let me try a different color. D, we're looking for the the average of the multiples of 5. So 101 divided by 5, take the floor of that, is equal to 20. So same process again. So this will be 5 times 1 plus 2 plus 3, all the way up to 20. All over 20, it's just 20 terms. And this will be equal to 5 times 20 over 2. There's 20 terms, remember. This is n over 2, so n is 20. And then a of 1, 1. A of n, 20. 21. Add them together, we get 21. We divide this. So this will get 10. This will be equal to 50 times 21 all over 2. Did I do something wrong here? 25. This seems too big. Sorry, let me backtrack. Oh, sorry, this should be 20. My bad. Alright, so this will be 2 and 2 cancel out to make this a 10. And then it will be 50 times 21 over 20. So then see that these two cancel out. 5 times 21 is equal to 105. 105 divided by 2 is 2 equals to 105. 5. And then this will be 2.5. So this will be 52.5. That means that the average for D is 52.5. Now we're almost there. E, we have to find multiples of 6. E, 101 divided by 6 is equal to 16. The floor function gives us 16, otherwise it would be 16.6, and 16.6 repeating, and 16.6 repeating. The 0.6 repeating is not a multiple of 6. So, same process again. 6, 1 plus 2 plus 3, dot dot dot, all the way to 16. There's 16 total terms. And this would be equal to 6 times 16 divided by 2 times 17 all over 16. This will become 8. The 8 will cancel out the bottom, gives us 2. So it will be 2 cancels out the 6, gives us 3. 3 times 17 looks familiar, which is 51. So we can see that the average of E is also 51, which is not right. And the greatest of these averages is D, the multiples of 5 between 1 and 101. This took a little bit long.